So today we continue with Unit 2 derivatives. We're just going to spend one day here, and let's start with our definitions. So pause the video, copy these all down, and see how many you can do on your own and get them right. So you'll notice I changed all my x's to monkey because we want to take into account the chain rule. So for instance, for sine monkey, the derivative, now keep in mind we're not taking the integral. That's backwards. We're taking the derivative of sine, which is just cosine monkey times monkey prime. The derivative of cosine is negative sine of monkey times monkey prime. So remember, when we're taking derivatives, if it starts with a co, this derivative will be negative. For these last two derivatives, sine inverse and tan inverse, remember these special formulas. The sine inverse is 1 over square root 1 minus monkey squared times monkey prime. And then the tan inverse has a plus sign. I remember that because it looks like the t. So plus sign inside. And then there's no square root. It's just 1 plus monkey squared times monkey prime. So here are the tricky ones. Not only will you need to remember your inverse functions, but additionally, notice that the derivative of 1 over monkey is negative 1 over monkey squared. Now that's tricky because some students confuse that with the integral of 1 over monkey, which is the natural log of absolute value of monkey plus c. So keep in mind, we're taking the derivative of 1 over monkey. It's going to be negative 1 over m squared. However, the integral, when we're going backwards, the antiderivative, that's this guy. The integral of 1 over monkey is natural log. So don't mix those up. Now looking at our rules, remember the product rule. We're going to first just take the derivative of the first, then copy the second. Then we copy down the first and take the derivative of the second. For our quotient rule, we have our handy-dandy little song, which is low d high minus high d low all over low squared. Why don't you sing it with me this time? Just kidding. Last one, let's do chain rules. So when we have a function inside of a function, we're going to take the derivative of the outside function first, hence the f prime on the outside. The inside guy stays the same, and then we multiply by the derivative of the inside guy. So just make sure you have all these rules down pat. Okay, so starting with number 1, it says find the third derivative of the function. So noticing that we're given the first derivative already, meaning we only need to take 2 more derivatives to find the third. So let's take the derivative on the left. We'll end up with f double prime of x, and the derivative on the right, copying down the constant always. The derivative of root monkey is 1 over 2 root monkey times 1, the derivative of x, minus 2, that's the constant, times, and we don't have a rule for x cubed in the denominator, 1 over x cubed, so I'll rewrite that. Actually, now that I've rewrote it, I can see that that negative 2 and negative 3 will multiply to positive 6x to the power of, subtracting 1 from the exponent, as we always do with our derivatives, leaves me with negative 4. Okay, let's clean this up. So 4 and 2 will cancel, leaving me with 2 over root x plus 6x to the negative 4. I'm going to take the derivative again on the left, and now we'll do it on the right. So copying down the constant always, that's 2 times, and notice we're left with 1 over root x. We don't have, if you check the formulas, we don't have a formula for 1 over root x, so we'll rewrite it as x to the power of negative 1/2. So let's bring that negative 1/2 to the front. X, subtracting 1 from the exponent, we get negative 3 over 2. Minus 24, x to the power of negative 5, because we're subtracting 1. Okay, let's cancel our 2's. And rewrite this bad boy. That'll be negative 1 over x to the 3/2 minus 24 over x to the power of 5. And make sure to show the left-hand side. And we're done. Now, you might have been thinking earlier for our 1 over radical x, don't we have a formula for that? It looks very familiar. And if you were thinking that, it's because we have a formula for 1 over root x when we're taking the integral. Now, the integral of 1 over x is 2 root x plus c. But when we're taking the derivative, right, we're going forwards, then you need to rewrite that as a power rule. So please, please, please be comfortable with your formulas, both forwards, derivatives, and backwards for antiderivatives. All right, pause the video and you try this one. So it's saying find the value of k so that this function has a horizontal tangent line. Keep in mind k is just a constant. And if we want a horizontal tangent line, hint, anytime we're talking about a tangent line at a specific point, we're describing the slope of at a specific point, we're talking about, hint, when we're finding the horizontal tangent line, horizontal tangent lines occur at maxes, at mins, and potentially at inflection points like this one. So what all of them have in common is that the slope at a specific point x equals 0. So that's the notation that we're going to use. Now, the x value that they want us to use is -1, so we're writing f prime of -1. That's what we're finding. Pause the video here and see if you can solve for k yourself. So if we're dealing with f prime of -1, we want that to equal 0. First, we should probably find f prime. So f prime of x equals 6x minus, and like we said, k is a constant, so -5k will just be a number. And the derivative of -5kx is just -5k. The derivative of 3 becomes 0, and that collapses. Cool, so that's f prime of x, but we want f prime of 1. Let's plug that in now. Everywhere we see an x. That gives me -6 minus 5k. And I want that to equal 0. So let's solve for k. We're almost done. And we're finished. So k, the constant that makes the derivative or the slope of this expression equal 0, making it horizontal, that would be -6 over 5. Okay, let's try number 3. It says, write an expression for the derivative of f of g of x. And they're giving us x value, and they're giving us g of x. So immediately I'm noticing I have a function inside of a function. Which rule would you need in this case? Yeah, we'll need the chain rule. So immediately, I want you to ignore everything else. Anytime that you're given something in this sort of abstract form, f of g of x or f of x times g of x, where they're not defined immediately, I want you to immediately apply the rule. So let's label this somewhat complex expression y, so that when we take the derivative, we can show that with y prime. So the derivative will be, chain rule says find the derivative of the outside guy first, inside guy stays the same, then multiply by the derivative of the inside guy times by the derivative of x, which is just 1. Now multiplying by 1 here isn't actually important, it's not going to do anything for us, but I want you to get in the habit. Let's say it had been find f prime of g of 2 of x. You would first find the derivative of the outside, and g of 2 of x stays the same. Then you'd multiply by the derivative of this inside expression. So you'd get g prime of 2x. Notice the inside guy is still staying the same, but then you'd multiply by the derivative of that. In this case, it didn't make a difference, so coming back. In our next step, we can now use the rest of the information that was given. They're telling me g of x is 2 sine x, so I can go ahead and plug that in. So I've plugged in g of x. To plug in g prime of x, I need to find the derivative. G prime of x will be 2. The derivative sign is cosine x, so that's what I'm multiplying at the end. In our last step, we'll need to evaluate this at the point given. So we'll show that like this. Y prime evaluated at x equals 7 pi over 6 equals, and now we're just going to plug it in everywhere we see an x. In our next step, let's evaluate sine of 7 pi over 6 and also cosine of 7 pi over 6, and then plug them in. 7 pi over 6 is 7 times 30, which is 210, so I'll be in this quadrant with a 30-degree reference angle. And sine is y over r, so y over r gives me negative 1/2, so that's 2 times negative 1/2. And cosine is x over r, so that's going to be negative radical 3 over 2, multiplied by that 2 in front. So finishing up, y prime evaluated at 7 pi over 6 yields f prime of 2 times negative 1/2, the 2's will cancel, times 2 times negative radical 3 over 2, 2's will cancel again. And so our final answer can be written like this, or if you move the constant to the front, as we typically do, this is an answer as well. Okay, number 4, find the instantaneous rate of change. That's just code for the derivative, or the slope of the tangent line, which is, we usually just abbreviate that m tan, or f prime of x. Please be comfortable with all of these interchangeable terms. So we're finding the derivative of this expression. Clearly we'll be using the quotient rule here. So let's sing our little song. F prime of x equals, first I need my low d high minus high d low all over low squared. Great, but just a little bit tedious. Make sure you're not making any simple mistakes. Carefully distribute. This second product, I'm going to move 6x since it's a monomial to the front and just distribute negative 6x all at once. It'll make it easier for my brain to, rather than multiplying 3 things. Now for my binomial being squared, I remember the shortcut, which is to square the first term. So 3x squared times 3x squared is 9x to the 4th. My next step is to multiply this times 2. So 3 times negative 4 is negative 12, times 2 is, and then we copy down the leftover variables. Okay, let's simplify. I'm noticing that these guys cancel. And we're done. So notice I always have a left-hand side in addition to my answer. All right, number 5. Given this function f of x, find the second derivative evaluated at 1 over e. Okay, this is going to be important in this problem. I just want to remind you 2 basic formulas, which are that the natural log of e to the monkey gives me just monkey. And similarly, e to the power of natural log of monkey is also monkey. So these are 2 properties which rely on natural log and e being inverses of each other, so they cancel out. And that's how that pretty much works. So let's keep that in mind as we do our problem. For number 5, we're using the product rule. So I'll first circle each expression. And the way I like to do the product rule, it doesn't matter which order you do it in, but I like to take the derivative of the first guy first. And then you multiply by the second guy that's unchanged, just copy him down. Plus, now I'm going to hold the first guy the same and take the derivative of the second guy. So if you did it backwards, if you copied the 2x cubed first and then took the derivative, plus then you took the derivative of the first and copied the second, you have the exact same thing, right? Order doesn't matter here because it's plus. But when it comes to the quotient rule, order matters because you have a minus in the middle, and whatever way you're subtracting obviously makes a difference. So it doesn't matter here, pick a way and stick with it. All right, let's simplify. We only have the first derivative, we need the second, so let's pretty this up a little bit. This x cubed cancels with the x at the bottom, leaving me with an x squared on top. Now, if we didn't simplify, notice that in our next step, taking the second derivative, we would have had to use the product rule, which is unnecessary and tedious, so make sure you simplify if possible. Let's finish up. The second derivative now will be, we're using the product rule again, so try it by yourself this time. Right, so I did the product rule and I got this whole expression, then I finished with the derivative of 2x squared. Let's simplify. And notice that these two combine. Last step, let's plug in. We always wait till the last step to plug in our 1 over e. Okay, so right here, it looks very close to one of the formulas that we discussed earlier, but notice e's in the denominator. So we'll have to rewrite it. If we rewrite natural log of 1 over e as natural log e to the negative 1, now I have this in a form where I can apply this rule. So natural log of 1 over e is really just negative 1. So we have 12 times 1 over e times negative 1 plus 10 times 1 over e. Simplifying, we get negative 12 over e plus 10 over e. Since we have a common denominator, we can just simply add. So our final answer is negative 2 over e. All right, you try this one. Pause the video and give it a shot. Did you catch that chain rule there? I hope so, because we have e to the monkey. The derivative is e to the monkey times monkey prime. The AP will accept any expression that's equivalent to the final answer. So you could have gone out of your way and simplified it to this step, or you could have actually just stopped right here. All right, number 7, find an expression for the second derivative. So I have an inside function and an outside function. I'll use the chain rule. And to make my life a little bit easier, when I take the derivative, I'll just call this expression y, so that I can show I'm taking the derivative with y prime. Because otherwise, to take the derivative, you might have to, it's like, do I write the derivative there? Do I write the derivative on the outside of the entire thing? So it's just easier if you call it y, so that there's no confusion over notation and you don't lose unnecessary points. Okay, a little pro tip for you. So y prime equals, chain rule says take the derivative of the outside guy first. So what are we writing down? Good, and the inside guy stays the same. Then multiply by the derivative of the inside guy. And if you like, you can write times 1, because the derivative of x. Now that we found y prime, it's time to plug in 1 over e. So we'll show our work like this. So we'll be writing g prime of ln 1 over e plus 1 over e. Or rather, times 1 over e. So we've got g prime of, and can you rewrite this using what we did before? Yeah, that's going to become negative 1. And then 1 over in a fraction is always just going to become the reciprocal of the denominator, because it's 1 over 1 times e over 1, which becomes e. So you can simply just take the reciprocal without doing that math. And so our final answer is e times g prime of negative 1. Need my left-hand side, and we're done. Okay, FRQs, it's really, really important that you have the left-hand side. So notice it's in all caps at the top of your homework. Don't forget your LHS, left-hand side. Number 8. Find the instantaneous rate of change. Again, translation, we're finding the derivative, or f prime of x. Add x equals e to the power 4, so we really want f prime of e to the 4. So let's get started. What should we find first? First, certainly we should find f prime of x. And notice that we have a function inside of a function, so we'll use the chain rule. So let's take the derivative of the outside guy first. Right now my monkey is the natural log of x. So I can just, like, in my mind, call that monkey. And what's the derivative of root monkey? Well, it's 1 over 2 root monkey. And what was the monkey? It was ln x. Since we had a chain rule, multiply by 1 over x in the last step. Let's plug in. So e to the power of 4 gives me 1 over 2. Pause the video, see if you can finish this yourself. So notice we have natural log of e to the power of 4, which just becomes 4. And 1 over e to the 4 stays. Okay. Number 9. Find the slope of the tangent line to this expression. So slope of the tangent line is the long way of saying m tan. And m tan is just another way of saying the derivative. It's the slope of the tangent line. So in this case, we're dealing with a trig inverse function. So let's remember, what's the derivative of sine inverse of monkey? Look back at your notes if you need. Otherwise, you should recall that it's 1 over the square root of 1 minus monkey squared times monkey prime. So let's plug that in. First, we'll always copy down our constant, which is 4 times. Now, in your mind, I want you to replace 2x minus 1 with monkey. So we can use our formula. The derivative of sine inverse monkey is 1 over. The derivative of sine inverse monkey is 1 over square root 1 minus monkey squared. In this case, monkey is 2x minus 1 times by the derivative of monkey, which is 2. So for our final answer, we have 8, 4 times 1 times 2 in our numerator over the square root of, okay, we've got some simplifying to do. Let's first expand 2x minus 1 whole squared using our shortcut. So it's going to be 1 minus, parentheses, because we'll distribute the negative later, 4x squared, this times 2, gives me minus 4x, and then plus 1. Distributing the negative, I get 1 minus 4x squared plus 4x minus 1. Notice the 1's cancel, leaving me with negative 4x squared plus 4x. Now, since we're doing an FRQ, you really could have stopped here. But I just want to show you how we could simplify this. We could factor out a 4. Left with negative x squared plus x. And then the square root of 4 becomes a 2 on the outside, leaving me with 4 over square root negative x squared plus x, because the 8 and the 2 can cancel. Okay, number 10. Find the slope of f of x at x equals 1/2. So very similar to the last problem. We have another trig inverse. We have another chain rule. See, this is tan inverse monkey. And in the last step, we're going to plug in 1/2. Pause the video and try this one on your own. So this is what they're looking for. What should we find first? F prime of x. So I'm plugging in my tangent inverse formula, the derivative, and my monkey in this case is x squared, so I'm multiplying then by its derivative, 2x. My new expression is 2x all over 1 plus, now x squared times itself gives me x to the 4th, and in the last step, I'll plug in 1/2. 2 times 1/2 is just 1. And then 1 plus a half to the fourth. Well, 1 to the fourth is 1. 2 to the fourth is 16. And I've got to simplify this complex fraction. So let's combine our denominator first using the fraction trick. 16 times 1 is 16, plus 1 is 17. So we get 1 over 17 sixteenths. And as we discussed earlier, 1 over anything is just the reciprocal. So our final answer is 16 over 17.
So number 11 says, find an expression for the slope of f of g of x given our f and g functions. We're finding the expression for the slope, then we're finding the derivative, and notice we'll be applying the chain rule. So as we've done before for somewhat complicated expressions, let's label this guy y. So y equals f of g of x. Therefore, when we take the derivative, we can have a left-hand side and a right-hand side. Y prime will equal derivative of the outside, inside guy stays the same, times the derivative of the inside. Like I said, you're ignoring these. They will get you into trouble if you immediately try to plug them in. So this is a much more efficient way of doing the problem, is apply the chain rule with the function notation, and now in the next step, we'll plug in. Notice we need to figure out what f prime is. We'll also need to find out what g of x is. Well, that's given. And then we'll also need to find g prime of x. So let's do it. F prime of x is 3x squared minus 6x. And then g prime of x will be 6x squared. So we can now plug in. So f prime of x will be 3x squared minus 6x. But notice that we want f prime of g of x. So we should replace our x's here with our g function. You can do it in two ways. You can literally write g in its spot, or when you wrote 3x squared, put parentheses and immediately plug in g, which is going to be a 2x cubed. Okay, so that's f prime with g of x plugged in. Now from that, with that, we have to multiply that with g prime of x. So let's show big parentheses. And then g prime of x would be 6x squared. Okay, let's simplify for our final steps. So inside this parentheses, 2x cubed squared is going to be 4x to the 6th with a 3 in front. Minus 6 times 2x cubed is negative 12x cubed. And all of that's being multiplied by 6x squared. We can leave our answer here, really, since it's FRQ, or we can take it a couple steps further.
All right, you try this problem. So pause the video, figure out what rule you'll need to apply, and what 2 steps you'll need to do to find the instantaneous rate of change at x equals radical e. So these are going to be our steps. Let's simplify. And finally, let's plug in. So I can use this rule. Natural log of e to the monkey is just monkey, and I can see that the power is actually 1/2. So I can simplify that. Notice the 2's cancel, leaving me with root e minus root e all over e squared, which is using the 0 over e squared, and my final answer is 0. So we're given a really complicated function, actually, but they've already named it for us, w of x. If they hadn't, we could have called it y. Use the table below to find w prime of 1. So we're going to find the derivative first, as always, and then last step, plug in the 1. Let's find w prime of x first. Notice we have a product rule first, and then we'll also apply the chain rule. Okay, so let's start with the product rule. The derivative of the first expression, 3x squared minus 4gx, will be 6x minus 4g prime of x. Do you see why I did that? Times the second guy stays the same as is. Plus, now let's switch. Let's copy the first expression. And now let's take the derivative of the second. Well, the derivative of f of x whole squared is going to use the product rule, or rather the power rule. So the 2 comes in front. That gives me 2 monkeys to the power of 1. So it'll be 2 f of x to the power of 1 times the derivative of the inside, which is f prime of x. Of x is, let us plug in 1. Everywhere we see an x, that's 6 times 1 is 6, minus 4g prime of 1. And all that is being multiplied by f of 1 squared, plus, plugging in 1 again, I get 3 times 1 squared, which is 3, minus 4g of 1. And all that is being multiplied by 2 f of 1, f prime of 1. So now we'll use the table to figure out all of these highlighted values. So all the hard work is done. 6 minus 4, g prime of 1. So when x is 1, it's showing me right here. So g prime of 1 is 4. F of 1 is 3. G of 1 is negative 3. F of 1 again is 3, and f prime of 1 is negative 2. So I have negative 90 minus, so my final answer is negative 270. But I need my left-hand side, so I'm writing w prime of 1 equals. Okay, check back in the next video to continue the classwork.